Well, welcome to the Open Team community for another installment in our in-depth series. Today we're going to have the Cool Farm tool present, and I'm going to hand it over to Daniela Mallon to introduce her team, and we're really looking forward to diving in. Thank you.
Yeah, pleasure. So glad to be here. It's been really so exciting to hear and see everyone else's presentation so far. So we're delighted to be part of this long lineup. And I'm just saying hello here for a minute, and I'm really gonna hand it over to Craig Simmons and Carl von Tonder. They are both from Anthesis. Craig is our project director, and Carl is the lead developer for the Cool Farm tool. So with that, I'll hand it on over. Thanks to you both.
Great. Thanks, Daniela. Hopefully everyone can see the screen and it's showing okay. Because for some reason it's the little line around it stopped. But yeah, so I'm Craig. I'm project director at Anthesis, and we're the developers of the Cool Farm tool. We're also members of the Cool Farm Alliance, and we do consulting in the area of agriculture and sustainability as well. So we're sort of connected in various ways. And just Carl, would you like to quickly introduce yourself?
Yeah, thanks, Craig. Hope my audio is also coming through okay. Thanks, Craig and Daniela, for the introductions. I've been working as lead developer on the online version of the Cool Farm tool for about seven years or so, I think, at this point. And I'll be going into some of the detail on the stack of the tool and the API that currently exists and current development on that once Craig's done a sort of more general introduction.
Yeah, thanks, Carl. So you can see just what we're planning to go through at the moment. We're just going to start with a little bit of context. And I think it's quite important, given the Cool Farm tool has been around for some time, to put some of that context is how we got to where we've got to, where we are in terms of the development of the Cool Farm tool. And then Carl will do a bit more deep dive into the technology. And we've tried to keep it short so we can have ample time for questions at the end. Some of the other sessions, I thought there were lots of great questions and there wasn't time to do them. So hopefully we'll have some ample time for questions. So firstly, sort of what is the Cool Farm tool? So just put that sort of context in. Well, essentially it's a farm metrics calculation engine available initially, primarily through its own user interface, but actually increasingly available over APIs, and that's been the focus of a lot of our development recently, enhancing and improving those APIs. There's a basic architecture diagram here. Carl will go into some more detail later, but essentially you input data sort of through a form-based system, through its own user interface. There's a calculation, and then we have results. The data's all stored in a database which you can access directly through APIs or data import export. There's a second sort of interface for members of the Cool Farm Alliance, and that allows them to look across farms, across assessments, and do data aggregation. So there is a mechanisms for enabling sort of Cool Farm Alliance member specific features by what we call group codes, and go into some of that in more detail. So say, for example, a member has a particular set of instructions they want to give all of their suppliers, they can enable a group code so they get those specific instructions only for their suppliers. Also, aggregations facilitated through a sort of sharing system. So a farmer will explicitly share their data from their assessments using a share code, and then anything allocated to a specific share code can then be aggregated. So it's a simple mechanism for recognizing permissions on data. Here's just an example of the sort of data inputs to give you a feel for it. This is for crops. So farmers enter essentially information about their crop, the type of crop it is, the residues, co-products, information about the soil, and there's some default data provided at various places through the system. Then get inputs into the farm, so fertilizer, pesticide applications, manure management, and then fuel use, fossil fuel use, use of energies or renewables, wastewater on farm, anything about irrigation, So irrigation events, pumping distances, power use for irrigation, and then land use change, so around tillage practices, cover crops, forest planting, land use change, and then transport of the crop either to or from the farm, and then they get the results. So it gives you a sort of feel for the sorts of data the farmer enters and the sort of results they get, and we'll get a little bit more into detail around that. I think it's important for people on the call to recognise that our sort of functional unit, our unit of analysis, is the mass or volume of an individual product. So it could be a crop or livestock product. So, for example, a ton of wheat or a litre of milk. But we are currently thinking about the need to move to a sort of product system as a unit analysis, because that helps with perennial crops, which are multi-year. It helps with crop rotation. So looking more at the product system rather than an individual crop assessment. But at the moment, we're based on individual products, whether they're livestock or crops. So I just thought, you know, if I was in, you know, a developer on the Open Team, what would I be interested to know? Well, just in terms of context, well, a little bit about maturity of the product, you know, what's enabled, how it's been internationalized, how it's governed, a bit about the user base, and a little bit about development roadmap. And I won't have time to go into that, just to sort of basically say there is one. So it's a mature product. It's owned and managed by the Cool Farm Alliance, which Daniela is a manager, and it's who have the mission to help millions of farmers to reduce their environmental impacts. So that's really the drive behind the Cool Farm Alliance and the Cool Farm Tool. It's free to farmers, and that's made possible by subscription fees from Cool Farm Alliance members. It's driven by very clear guiding principles which have been agreed for many years now in terms of how it's run and operated and the benefits it delivers, and I'll go into that in a little bit. Second, it developed out of an Excel spreadsheet, so it had a very long history as an Excel spreadsheet before it went online. So it's gone through numerous sort of applications and testings and revisions and improvements and enhancements over time. As Carl mentioned, it's been online for 7 years now. So again, that's gone through a number of different versions and iterations. In fact, last year, also the year before last, we launched version 2, which had some major improvements. It's fully maintained and supported, again, through subscription fees from members. It's well documented, so it's a sort of well documented piece of code. It's version managed, and we're enhancing some of that version management work at the moment. As it's got more sophisticated, we've recognized the need to improve version management. But you know, the APIs are versioned, for example, and the code releases are versioned, and it's already integrated into a number of third-party systems. So we've already worked with a number of other technology partners to sort of integrate mainly the calculation engine within the Cool Farm tool. Those guiding principles I mentioned, which sort of guide sort of steer the development and the roadmap and the ethos behind the Cool Farm tool, you know, which led one of the reasons why it's free to farmers, is it's very much farmer focused. So everything we do, we like to test in the field and make sure that it works for farmers. It's science-based, so you'll see we have an academic committee and strong academic links to make sure we always reflect the best science. It's member-owned, so really decisions about development are made by the Cool Farm Alliance members, who are industry members. So they're people within the agricultural, sustainable agriculture food supply chains. It's meant to cover all crops and livestock, so we don't want it just to be a sort of dairy tool or a tool for potatoes or anything like that. There are some very good specialist tools around this. It attempts to cover all crops and livestock and at the global level. So that's also another important guiding principle. Things which just work in one region of the world wouldn't really work within the Cool Farm tool. That has advantages and disadvantages. Obviously, we have to stick with sort of globally recognized algorithms and data sets. But it also has advantages, is that people with global supply chains can be confident using it in any part of the world. And it's multi-metric, so over time it started as a primarily greenhouse gas calculator when it was an Excel spreadsheet. Since then we've added water, footprinting biodiversity, waste, and we have a series of performance KPIs that people have asked for, which are things like, you know, cost per ton of beef or nitrogen use efficiency. And also, you know, we've incorporated a simple cost model as well. Just as said, the Cool Farm tools evolved over a period of time. 2008, it was a spreadsheet, and you can see that memberships increased. Whoop, someone's yawning there. It's developed over time. It went online in 2012, and we've added a series of capabilities and features, including multilingual capability, internationalization, enhanced APIs over time, and we're still working on the roadmap for the next series of developments. Here are our data exchange partners. So we currently do it for crops, and here are the sort of partners who integrate into the Cool Farm tool. Some of them do it through data import export, others do it through sort of direct API calls. A little bit about internationalization. So it's used in 118 countries. As I mentioned, the sort of advantages and disadvantages, we have to use sort of globally recognized and globally complete data sets and algorithms. So primarily we're based on the IPCC formulae. It's available in 11 languages at the moment, and obviously we have full international units and currency support. So in terms of usage, it's just ignore the user numbers there. This is a slightly old chart, but you can see primary uses is in North America, Brazil, Latin America, Europe, Australia, Asia, India. So that's the main areas where the users come from, but you can see there's pretty good coverage of users around the globe. The governance model, you know, affects very much the technology development process. It's CFA is a community interest company. It has 70 plus industry members and a series of, sort of academic and technology partnerships. We do an agile development process, have quite a formal development process we go through with a sort of committee structure and how we work for all the way from a sort of academic idea or academic piece of research through various working groups to a sort of methods group and through a DevOps committee to actually make decisions on what goes into the tool and what doesn't. But it is an agile development process. We use agile development toolkits and you know, have proper prioritization and sprints, manage our releases through sprints. We have very active stakeholder engagement via the committee structure, which I alluded to. So lots of people are engaged at various levels. Lots of people give their time voluntarily to make the Cool Farm Alliance happen. It's a very sort of lightweight organization in terms of staffing, but a lot of it runs through the goodwill of the membership. And here's some of the sort of members of this Cool Farm Alliance. You can see everyone from Unilever through sort of Fertilizer Europe to some of the sort of fertilizer companies are quite active. A lot of the brands, PepsiCo, are quite active. And you can see some of the academic partners in there as well as the global big brands. I won't go into detail about this, just to you know, show you that the governance, the way that the software is governed, is quite sort of rigidly governed in terms of the process from science all the way through to deployed software. We go through a sort of formal specification process and, as I say, deployment design process, and have staging versions of the code which go through testing and before release. So, and documentation is always kept in line with that. So it's a very formal development process. So born out of the complexities of working in a multi-stakeholder environment primarily. Users, we have sort of rising membership, member-funded improvements. So we get a lot of engagement, financial as well as in terms of time commitments from members to fund improvements over and above the basic maintenance support. There's an annual conference where users of the Cool Farm tool meet and discuss ideas and hear about and input into the development of the tool. But obviously year round there are active meetings of working groups discussing dairy or perennials and various other parts of the Cool Farm tool. And also, as I mentioned, a lot of stakeholder engagement in running the Cool Farm tool. The membership is now over, well, in terms of the numbers of users, it's over 8,000 who use the dedicated user interface, but thousands also use the APIs, as well as using the interface directly. And so you can see that that's steadily increasing over time. And just concluding, and I've gone rapidly through this because I promised Carl lots of time to discuss the in-depth deep dive, is the development roadmap. So we do have, you know, a reasonably well planned 2-year, although it's like all these things, it's a bit fluid. We have a 2-year roadmap where we've decided where we're going to next. There's a lot of effort, for example, on multi-year crops, perennials, quite a lot of work being done on soil health and looking at soil carbon markets. And waste is on our staging server, ready to be launched, where we've got sort of food loss using the International Food Loss and Waste Protocol to look at sort of on-farm and off-farm waste. So we're going to have questions at the end, I think, Dawn, but if anyone has any sort of points of clarity they want, now would be a good time to speak up.
And I also encourage folks to use the chat window as we're going, so we can, as you have questions during the presentation, we can catch them at the end as well. So I think we should keep rolling.
Yeah, great. I see there are some things in the chat window, and I'll certainly pick those up at the end. Okay, Carl, over to you.
Brilliant, thank you. And yeah, if you wouldn't mind paging through these slides as I talk, and then we can swap for the API demo, that would be fantastic. Thank you very much for the introduction, Daniela and Craig. As I said, I'm going to very briefly go through the technology stack, the supporting tools that we use in developing the Cool Farm tool, the calculation architecture, and then do a brief word about the opportunities for development of the CFT and the integration with it, specific to the open team context. And then lastly, sort of in service of that, a whistle-stop tour through the API. And as Craig said, we're very keen to leave decent time for questions at the end, because I think the most useful incarnation of this session will be if we can deal specifically with any areas of interest that become apparent from your feedback. So please give thought to that as I'm talking, if you have any moments between the words. The technology stack, this slide, we are using Django, a standard Python web framework, to handle the request response cycle for the user interface, and also the object relationship manager in terms of providing the API. We're using what was formerly a MySQL, now it's a MariaDB database for the main Cool Farm tool, including reference data and user data. There is a Postgres database in use for the CFT water module to hold all of the annual rainfall data that's used in that calculation. And there is a hope to migrate to Postgres in the medium term, but for the moment, that's where we've landed. For the front end, it's mostly jQuery. It's a progressive web application for the most part. It works reasonably well on tablets and serviceably on mobile phones. We do have a couple of parts of the application which use rActive.js, which is a modern component-based framework for end-user interfaces in JavaScript. That's probably the direction of travel for the main user interface, depending on its relative usage versus the API going forwards. As Craig mentioned, the Cool Farm tool is translated into several different languages, and that's done through standard getText tools, which means that the interface for translators is relatively easy, and there's good toolchain support for potential future integration into something like WebLake. And then lastly, and I'll come back to that at the end, we're using Sphinx for generating developer documentation, including API documentation, mostly from comments in the code. Craig, if you wouldn't mind paging forwards. Thank you. In terms of supporting tools, We're using Git for version control. There's a development team of between 1 and 3 coders that's been working on this for the last several years. And we coordinate between ourselves using Git. We're in the middle of migrating to a new ticket tracking system at the moment, which is that bottom right-hand set of question marks. So watch this space, but whatever we choose is going to be an open source platform with probably strong opportunities for collaboration in terms of raising bugs and responding to queries and things like that. We use Ansible for server provisioning, which helps people get set up. So I'll talk about it in a second in terms of the development environment, but were you to try and start your own Cool Farm tool instance, it's relatively easy to do that because of the playbooks that we have within Ansible to provision a new server. And then we do have continuous integration testing set up. We have several automated tests across the various layers of the Cool Farm tool, and that's currently managed using GitLab's CI runner. On to the architecture. So natty diagram, I was going to talk through this just to communicate a couple of core concepts, because probably the most frequently asked question we get around the Cool Farm tool is about access to a database of results. And there's been a deliberate architectural decision not to maintain such a database so far, and I'll be interested to see presentations from other agricultural calculators specifically to see how they've handled this challenge. But so far, the requirements around data management, as well as the complexity of the calculation involved, has meant that our architectural model at the moment is that if you request a result, then that's calculated on demand each time. And there is some caching going on, but versus other tools where there's a sort of single SQL table that has assessments against results. Currently, that's not something which the CFT has implemented, and that's, I think that'll become clear in a second when I talk about how the APIs ended up being used. Another point to note on the architecture, because I've learned that this isn't necessarily the case in other systems, but the user interface and the API are using exactly the same calculation code. So regardless of the pathway, you're still accessing the same results. And I think that's important because of what Craig was saying about the academic and the methodological weight behind the tool. That's equally supporting the user interface version as the API. And then lastly, just to note that the reference data and the user input data is stored in the database, as I mentioned. So that does mean that it's possible to directly sort of do bulk operations on that data for a third party. That's not an interface we've currently implemented, but I will probably now move on to the general landscape of development and integration. So I think that's been a question which has been on our minds with regard to OpenTeam, is that versus some of the other partners where there's a very easy path to contribution, the collaboration that's happened so far with the CFT has either been specific academic projects, or it's been from Cool Farm Alliance members requesting the source code and then developing an integration against that in collaboration with us. So there have been routes, even though it's a closed source project, there have been routes into the development process. And this second point is something which I'm not sure of the exact status of within the Cool Farm Alliance, but I think the hope is to provide API access to project partners, at least for the duration of the initial 3-year OpenTeam effort, to be able to to leverage cool farm tool calculations with a view to future integration. So I think that's probably a conversation which needs to continue across the Alliance and also respond to whatever needs there are from Open Team. But moving specifically and finally onto the API, and Craig, can I try and wrest control of the screen share from you at this point? Wonderful. Desktop 1. Okay. Can people see the API documentation currently?
Yep.
Yes.
Wonderful. Thanks for the feedback, for the audience participation. So as I mentioned, we use Sphinx for the for generating the documentation. That means that it's kept in sync with changes to the code base. So as long as you're consulting the version that's relevant to the deployed version that you're looking at, which if you're running your own copy, you will have tight control over, you will see up-to-date information. There's a topic guide on the API, as well as information on the data model. So I'm just skipping to that. We have the basic information on the data model of the tool, showing the way that the different entities interact with each other. We also have a topic guide, which is more of a quick start guide for partners writing applications using the API. It's a fairly standard HTTP JSON-based API, and it broadly follows REST conventions, as we'll see looking through the URLs. There are basically 3 types of API endpoints. What we loosely term GET, all of the requests which fetch information, either user or reference data, from the tool. That could be used for loading CFT data into your application, user by user. It could be looking up reference data that we have, and we could, in theory, build that out in future to give easy access to aggregated emissions calculation results. The second type of API call is put, which is calls which save information to the CFT. And this, I think both of these have been dwarfed in usage by the calculate API, where rather than relying on user data that's stored in the tool, you send all of the data necessary. So for instance, here on screen is calculating the GHG emissions from a crop product. And this, I think part of the reason for its wide usage has been, as I mentioned, it's an industry in which data protection is important. And for third-party tools, it's been an advantage that it hasn't involved saving data on a third-party system, which has been something of an unknown quantity. Additionally, for systems which are themselves farm data management systems or agronomy software packages, which already need to house a lot of the data relating to, probably more data than the Cool Farm tool relating to the farming practices, then it prevents duplication and the need for synchronization. So what if someone updates their data on a third-party tool, and then the complexity of needing to reflect that change back into the CFT. And it also means that if you're one of those warehousing or agronomy tools, that you can present the GHG and potentially the water metric that the CFT calculates alongside your other metrics. The only disadvantage to using the Calculate API, and I think something that we're open to suggestions on from any API partners, is that it doesn't provide a route into the CFT for further analysis. And it really, there's a quite coarse maximum granularity that you can descend to when you're looking at results that are returned from those, and saving things in the CFT for further analysis. So, of further minutes to highlight the presence of this HTML JavaScript tester. For anyone who's used Civi CRM, this is reasonably similar as a sort of API explorer. You can choose between the available endpoints, you can choose which server you're operating on, fill in your authentication secrets, and optionally fill in data if you're performing a calculate request, and the system will send it off to the selected server and allow you to quickly evaluate your API calls. The documentation also includes some examples in Python. So in terms of developing in Python or JavaScript, we have you covered already. And it was great to see that there were further supported languages in the FarmOS demo last week, and I think that's something which we'd love to move towards in time. Let me just quickly. So this is using Python's common requests library to show the use of both the get and calculate APIs in the Cool Farm tool. You can see it fetching a list of crop types by sending a request to the crop type endpoint, and then using one of the values returned from that to calculate API call. And that brings me to the last thing I wanted to cover, which is that the API has been in heavy development over the course of the availability of the Cool Farm tool online. And I think that that's something which is, so far the Cool Farm tool has avoided taking a strong stand on data interchange formats. We've mostly adapted to what the needs of the data model have been. As Craig mentioned, it's mostly IPCC, GHG accounting, and where necessary, meeting in the middle between that and what an API partner application has been doing. So there has been some flexibility built into the data format, but also I think there's a reasonable amount of accumulated wisdom as to what the different types of agricultural data need and what's required to interface between them. So I think I'd like to pause there for questions, as specific or broad as you like, because as we said, I think this would be most useful if we can focus on your areas of interest. Thank you all for your attention.
Yeah, thanks, Carl. Yeah. Shall I take, well, I don't need to take back control, but we've got some questions I can see here. Dawn, do you want to sort of chair this session, or do you want me just to go through them?
Sure. I mean, I think we could take them in order. It looks like both Mike and Greg have some different questions. Maybe take Mike's first on the API documentation.
So I can answer the first question very quickly. The API documentation is available to Cool Farm Alliance members and on request to the Cool Farm Alliance. So Daniel, I don't know if you can expand on that anymore, what the policy would be around making that available beyond the membership.
Right. No, I mean, I think what you said, and we've gone into the Open Team project with the assumption that we will share it in this context.
Yeah. So, and the second question is about mentioned tool is closed source, but also it's possible to run your own copy. Are these two different things? Can you clarify? So we have had, I think the best way of putting this, and maybe Daniel or Carl wants to chip in. But we have had members who have spun up their own instances of the Cool Farm tool. Obviously, then that creates a sort of branch, and that instance is no longer developed. So we wouldn't encourage that. But one particular member has done that. We also have spun up separate instances that we've maintained control of and kept within our sort of source code management system, where we've made modifications for a particular member, or we've put a version together that members can use for testing a particular feature that's not yet deployed. And indeed, one of the advantages of membership is you get sort of the CFAs, you get sort of early access to features that aren't deployed on the live site. I'm not sure that great, that makes sense. Good, excellent. That's answered the question. I must admit, Greg, do you want to ask your questions? Because I wasn't entirely clear at what point of the presentation they referred to.
Yeah, sorry, this is really early on. So it calculates like greenhouse gas emissions and stuff like that. Can you just talk about like how that's directly useful for a farmer in Europe, like in your actual applications, either in the supply chain or outside of it, and how that may apply to someone like in the US? Because I think those markets are very different, and where and how greenhouse gas emission calculations get used to access markets or differentiate are different between the two. So just like talking about the value of, I guess, that different spaces.
Well, we have a lot of users, of course, in North America, Canada, and the United States, who do find it useful. And maybe Daniela's probably, she's based in the States, in Vermont, so maybe you want to talk a bit more about some of the projects you've done, the case studies, and how people have found it useful.
Yeah, I mean, I think the overall concept, it really developed, in the absence of carbon markets at the time that it was going to get developed, is how else to bring visibility to carbon sequestration in particular, but also greenhouse gas reductions as they take place, and how to do it in a sort of pragmatic and streamlined way as possible, so that it could become part of the culture of procurement. And that's really sort of where the Cool Farm tool came in originally, from Unilever wanting to take the climate change mitigation potential available through agriculture to their supply chains everywhere, and look, no matter what the crop was and where it was grown, at a sort of a gap analysis. What does the current practice look like, and what could it look like, and what would it take to close that gap, and really bring the whole conversation around climate change mitigation to agricultural producers. And then as time has moved on, it's starting to become really a vehicle for reporting against science-based targets for multinational companies who need a consistent approach for the various crops that they source, whether it's US or Europe. And so science-based targets, CDP, and now, with gold standard and the value chain guidance and scope 3, GHG protocol, scope 3 guidance around agriculture, all of that really kind of leads directly to a tool like the Cool Farm tool. Same with Project Gigaton out of Walmart recently. These are all tools that require suppliers to provide a greenhouse gas assessment for their agricultural crop. So that's kind of where the Cool Farm tool comes in. Let's see. I guess I'll pause there. I mean, there's definitely other other ways to go with it. I mean, it starts to, then we start to integrate with LCA analyses, and I can talk a little bit about that as well. But or the European what is it, product environmental footprinting, and the legislation going on. But those are, so there's different levels of sort of methodological alignment that we can.
Along those lines, I'd like to just ask a question in terms of on the architectural perspective, how you're handling the translation tables or libraries for languages and units, and maybe speak in terms of the sort of the modularity of the current architecture and sort of where you see that going in the future. Especially, that's certainly important as we're looking at sort of software services and creating some common libraries that we might be able to share across the open team ecosystem.
Carl, do you want to kick off on that? Or
That's
Yes.
probably a few questions, but
yeah.
So in terms of managing the translations, that's one I can answer reasonably swiftly. I'm just trying to do right now. As I mentioned, we use gettext, which is a fairly standard format across software projects, both desktop, mobile apps, and web apps, which means that you can use tools like POEdit, which is the open source tool, Weblate, which is a web-based equivalent, a text editor, sort of commercial translation platforms. And all of the text from the Core Farm tool, both reference data and interface strings, is represented in these catalogs. So hopefully that answers your question about the architecture of the translation. In terms of the units, that is a system that is a separate application within the Core Farm tool. So in theory, it is reusable for other Python projects in particular. And that handles conversion between different quantities, and with the upcoming database versioning feature will also handle updates to those conversion factors. So for instance, when global warming potentials are subject to revision or similar changes. And then in terms of the modularity of the tool in general, there is reasonably good separation of concerns between the crop, dairy, other livestock, and water and biodiversity calculations in terms of application architecture. I'll stop there. Daniela, Craig, I don't know if you want to add anything.
Yeah, no, I was just going to say, maybe Dawn, you were sort of alluding to something else. If not, it's you raise a good issue. It's around sort of naming conventions generally, which are talking about sort of how to improve interoperability and come up with some standardization. You know, we have for some time been talking to people like Godan and Ag Gateway about sort of, you know, standardizing things like fertilizer names and farm equipment names and even crop names. And we haven't adopted in those areas any standards, but this is something we're very, very keen to talk through with other open team members to see. We've got some thoughts, you know, we've done quite a lot of thinking around it, but certainly we haven't yet settled on any particular standardization. Obviously, when you add in the language translation, it adds in additional complexity to all those things. You know, do we want a standard translation library for fertilizer names and for farm equipment and for crops? Yes, the answer. Is there anything out there that we've seen that does that? No. Open Team would seem to be a good vehicle for making that happen.
Yeah, I was thinking specifically about the presentation we saw on the plant data service as one example, and certainly, and I think the unit translation relating to greenhouse gas measurement, I think is particularly relevant, and perhaps you spent quite a bit of time in that, and maybe in a unique position to in that conversation as we try to move towards translating ecosystem service markets across across continents. So yeah, I'm just keen to sort of flag that for something that where as we connect, we may be able to have some linkages between the teams to talk further about that.
Yeah, no, exactly. I mean, we cover most of the key ecosystem services, but there's lots of room to improve that. And obviously, we don't do the ecosystem service valuations or any of the trading or any sort of market-based mechanisms built in. But obviously, we've got a lot of the potential raw data that can be used for those sort of markets.
Yeah, Mike, not to put you on the spot, but I'm curious from your perspective and PharmOS, and thinking through some of the interaction with both libraries and services and API, just to get some quick comments.
Yeah, I think that all makes a lot of sense. And I just said in the chat that I think naming conventions in general are, kind of a common hurdle between a lot of the platforms that we're all presenting on. So I'm excited to talk through those kind of things. And the translation, we take a very similar approach in the PharmOS system for how we handle translations. We actually get a lot of that out of the box from the platform that we're using, but units in general are also a challenge, and we've had a lot of discussion about that. Right now, we're using a pretty flexible approach just so that we can allow for farmers to track things in the ways that they need to. But I think the plan in general is to kind of start honing in and moving towards a more strict approach to that. So I'm excited to kind of talk with these other groups about how we can merge ideas.
And along those lines, Greg just posted in the chat that since we've most of the folks on the calls have been on the other calls, he's curious to see what has been most interesting to you and aligns with where you'd like to move. And I think this is really a great question for us to all think about as we're heading into the Denver event, thinking about sort of where we're going to focus our efforts during that limited time.
Yeah, no, it's a great question, Greg, and we're still feeling our way, I think, and Daniela and Carl sort of maybe at different stages at that as well. But I think there's obviously a lot of really great work being done in the agricultural space. Loads of work, as Mike says, that lots of common challenges. Nomenclature being one of them, and standardization. So I think if we can start to agree on ways forward on these, look at interoperability issues between the tools, see where there's added value that might be delivered mutually. Obviously we've got a user base which will help maybe bring some other people's ideas to an audience, but also we can learn an enormous amount from some of the more detailed work that is done for geomapping, for example. We don't do a huge amount of geomapping, and there's clearly a lot of that available. There's a lot of people who have access or provide visibility and web services around data that we could use. So yeah, I mean, there's a whole range of areas, and I think we're just at the early stages of understanding what those opportunities are.
And I'd like to hear a little bit about you mentioned that you are working within the Alliance with a number of partners through the API, and I'm just curious how much of that is sort of pulling data out, and how much have you been able to pull data from other farm management systems in for field level or whole farm level data? For sort of reducing the data entry.
Well, I think Carl and Daniel, correct me if I'm wrong, but almost all those integrations have been using the Calculate API. So people like Syngenta and Danone and PepsiCo, they're basically taking data from their farmers, raw data that they capture through various farm management systems, or data that's submitted from their farmers and in their supply chains, and they pump that data into the Cool Farm tool and get the water, the carbon, whatever results back out that they use for their reporting, for their supply chain reporting. I think that's the predominant use. There are people like Side Platform who use it for individual discrete calculations to provide sort of different levels of metrics to support their general sort of farm management systems. But I think probably the Calculate API in the sort of use cases I describe is probably the most predominant use. But Carl, Danielle, do you have any other insights?
I think that's absolutely correct. And I think that all of the API deployments have been an attempt to reduce the data entry requirement on producers. As Craig says, a lot of that so far has been through Calculate, but that's mainly been because the data is already stored elsewhere. If there were an opportunity for the CFT to act as more of a receiver, so I guess sort of smart farm equipment or climate sensors or other remote sensing technology, then the groundwork is laid for that. But so far it has been, as you say, more integration with farm management systems where the data is already present.
Yeah.
Yeah. Go ahead.
So I'm just saying, we do use external data sets. So Carl, maybe you want to talk about a couple of external data sets, but they're not they're embedded rather than used over APIs.
Got it. Yeah, I'd like to hear some examples of some of those.
Carl, over to you.
Yeah,
soil and
sorry,
water.
can I just clarify? Yeah, was that a question about?
Yeah, that was a question. Yeah, so for example, so what type of external data sets that are generally?
Oh, sure, absolutely. Yes, I didn't know if you were asking about other apps that were using the software, but no, in terms of external data sources, we're using the ERA interim global rainfall data set, which is released out of Reading University for the water module in order to calculate blue and green water footprints. And we're also using the harmonized world soil database for lookups within the water module. I think those are the two largest data sets that we're using.
Soils. What about soils data?
Were you asking me to repeat?
Yeah, that's a question. Yeah, whether that's manually entered, right? You enter. I'm trying to think back. I think you actually enter your soil texture, right, manually.
So there's default data provided.
Yeah. Right.
For the water module, we look at the harmonized world soil database, which has soil type and texture data globally. I can't remember what resolution it is. I think it's either half a kilometer or a kilometer grid square.
Right.
But that's not yet in use on the GHG platform.
Great. Yep. So sort of follow up on my earlier question, actually, on the for the data input from your supply chain partners. They're using a variety of different farm management systems that they're pulling data from. To the extent is your supply chain partners are largely aggregating that themselves and then formatting it to push it into your API. Is that correct? There's a supply chain processing step in there. Is that in general?
So yes, I think it's fair to say that most of one of the issues we're developing the APIs is we don't have great management, to be frank, of the APIs. A lot of people, we know who has access to it. Obviously, it's through an API key, authentication key, but we don't really track API usage. So we don't have many stats on how regularly or frequently it's used. We just obviously know when we can look at how it is used and who's using it, and so we know, but we don't know the volume of use. But we know lots of people put thousands of data from farms, individual crop assessments through the Cool Farm tool and get out sort of results. Most of them already aggregate that data, as you say, but it's normally sort of rows of data, individual data from a crop on a particular farm, and then they put that information through and they do that analysis. They don't aggregate in terms of across farms. They put in
okay. Yeah, that I was sort of trying to get. That was kind of what I was trying to get at.
Yeah, yeah. But also a lot of people do require their suppliers to use the Cool Farm tool, and then they can aggregate from within the Cool Farm tool. So that's also possible, and that's also a use case.
Let me just add a little bit. So, I mean, in some cases, it's a matter of like a big project to batch up a bunch of data and pass it in or use the API in that batch format. But in other cases, the supply chain partner might simply ask the main farm management software that their suppliers are already using to wire up with the Cool Farm tool. So it's not a batch. It's not like a management of a
So
I just if I could add one more application. I was talking to someone yesterday who works in the biofuels industry, and it feels like a really appropriate application. That's what I was asking about markets. So they have things like ethanol plants in the US that are trying to sell into the European market. And there's actually GHG offset requirements to be able to sell ethanol into the European market. And it was recently raised to about 50%. I think it's 50%. So a lot of corn ethanol plants in the US can't actually offset that amount, but some can or are close. So they're always looking for ways to increase their GHG offsets. And so he was talking about this sort of clause where they actually can use change in farm management practices and resulting GHG benefits from their suppliers, so the people growing the corn selling to the corn ethanol plant, as a way to produce GHG offsets for biofuels. And it's important because, one, there's an existing carbon market that's robust and has been around for a while for biofuels-based carbon offsets. And those are the highest value carbon markets for carbon. It's like, I think the California market, it's like $100 to $200 a ton. So it's a way to look at carbon offsets in the ag markets, which are relatively underdeveloped, and convert them into quite well-developed carbon offsets in the in other markets, like in biofuels. And like the Cool Farm tool, because you're focused on GHG reduction, is a perfect example of how to do that. And if you're talking about a big ethanol plant where they've got 1 million acres potentially supplying a single ethanol plant, like I love the idea of like combining your tool with something like Optus, where if they're trying to collect data from 1,000 farmers, like in your supply chain cases, that's going to be quite difficult to do. But if you can get some data from something like Optus, they could potentially capture the GHG offsets from their, from a supply chain for something like an ethanol plant to be able to sell into the European market. It was just a really interesting case that utilizes a lot of the tools I think that we've seen so far. So I hope, yeah.
I think it's a great application, and it sounds like it would be something worth pursuing.
Yeah, Greg makes it's a very interesting point that there are multiple ways as we add in these of gathering data that perhaps we haven't previously thought of to run these models. So that is exciting. We're at the top of the hour, so I just want to thank everybody for joining us, and look forward to the next round of presentations, and we'll be in touch. We will, and thank you everybody for being understanding as we're scheduling so many of these quickly. We've had some schedule changes in short notice, and we're all bearing with, and we'll be posting these usually within a couple days. It'll be live, so feel free to share them with folks who weren't able to make the call today.
And we had one more added on Friday. I think we added the Open Land Map, the Open Geo Hub guys on Friday, August 13th. So that was recently added to the calendar, just FYI.
Great, yes. And we'll look forward to seeing you all at the next in-depth series. Thank you.
Great, thank you very much.